is Nathan Cruz with Carlson Software, and in this video I'm going to demonstrate how to use Precision 3D to bring in survey data collected for ground control points for aerial drone photos, and then how to export them to a format that works seamlessly with our new Carlson photo capture image processing software. So the first thing I'm going to do is I'm going to verify that my current scenario projection is set to my local working area, and in this case it is Kentucky North, U.S. survey feet. You'll also want to verify that your units match. In this case, I'm using U.S. survey feet. So if you were using a metric data set, you would want to use metric units. And that way the import and the export goes as smoothly as possible. So make sure your units match your projection units of measure. So I'm going to go ahead and import a Carlson CRD file. And in this case, I'm going to pick the Maysville drone control. I'm not going to apply a projection because we collected this data ourselves, and we did save the data from Carlson Survey in the same projection system that I'm using and the same units of measure that I've got set up in P3D. So I'm just going to select OK. Because we're not applying a projection, it's prompting me for the units of measure just to verify, and it is U.S. survey feet. Get a little preview of the points, so I can see I've got a few extra ones in here. And I happen to know that I want, that I don't need these points. I have a Lewis and Clark monument, a 90-degree corner bend. So I basically have, looks like four really good ground control, 4 or 5 ground control points in here. So now to make this process simple, what I'm going to do is I'm going to save a land XML file. I'm going to go to the same directory, and I'm going to call it Riverwalk Control Points. And I'm going to save that. So now I've saved my land XML file that only contains these coordinates. They're in the proper units of measure, and it will be in the proper projection system. Now I'm going to go ahead and launch Carlson Photo Capture. If in this case I had already been logged in and it remembered that, if you don't have a Carlson Photo Capture account, you can create one in less than a minute by just putting in your first and last name and your email address. No credit cards required or anything like that, and you will have about 8 gigabytes worth of free data that you can basically test out against. So what I'm going to do is I'm going to create a project, and we're going to call it Maysville. It is a drone project, and it's going to use meters. So this is an important thing to remember, is that the output from this process is going to be in a metric data set. So the first thing I'm going to do is I am going to drag and drop my Riverwalk control points that I just exported down to the ground control, and it's imported those just fine, all 5 of them. The next thing I'm going to do is I'm going to go to my images that I downloaded from the drone, and I'm simply going to select them all, and I'm going to drag and drop them onto the image window. So now I've got all my images. I'm just scrolling through to make sure that I've only got the images that I want in here. I've got my control points, and we're done. This warning is basically saying we've got a high level of precision in the data that we updated, since it was GPS ground control and we exported with high precision. This is just saying that the data is out to 8 decimal places instead of 4 and is harmless. Now this is and it's giving me a nice preview here. So this is the Maysville area and the riverfront where this was taken. You can see the purple highlights are the ground control points that I just uploaded. You notice that we get the point number and the description next to each one of them, which is very handy when it comes to making sure that they're on the right spot in the photos. Now this coordinate system, I'm going to go down and use a Kentucky North NAD. So this is still going to be in meters when we're finished. So that's something that you need to remember. And I'm going to go ahead and create the project. And now what's happening is it's uploading all of the images to the Carlson photo capture website, and it is beginning the entire process. And now what's going to happen is the email that that you use to create your Carlson photo capture account will be used to notify you of when certain processes are finished. So right now it's telling us that it's 2 of 89 and it's in the upload process. And what I'm going to do is fast forward through this. This can take a few minutes. Now the upload is complete. Took about 10 or 12 minutes. And now that the Carlson photo capture web application is now working on doing the bundle adjustment for the GPS locations of the images and also our ground control points. And so the nice thing about this process is this is all grinding away and doing lots of work on the web server, and it's not taking up any CPU time or memory on my local machine, so you can continue to do work and other things. And when the bundle adjustment is finished, we'll be notified via email. And once we do, then we can go in and verify that our ground control points are exactly where we want them to be on the images for further processing. So this video will pick up when we get the email notification to complete the bundle adjustment, and I will show you that. So I received an email notification saying that my Carlson photo capture project was ready to view the results of the bundle adjustment and to have me basically verify these ground control points. And so it's going to step me through each one of the ground control points that I uploaded via the LandXML file with drag and drop and verify that it's in the right location in the photos. And in this case, I could see that my ground control point should be right on this monument. So I'm just going to click on it, and left click on it and drag it over until it's on the monument, and I'm going to accept that. Okay, and now I'm going to go to the next ground control point. And in this case, it is right here on the corner. And I'm going to accept that. And I'm going to go to the next ground control point. And I know that this point is supposed to be right here on the corner of the pad. See the little mark? I'm going to accept that. And go to the next one. This one is right on the corner. And I'm going to accept that and go to the next. Let's see, and in this case, this is supposed to be right here, and I'm going to accept that, and I'm going to finish. So I did the first one a few times. So if you mess up, you can basically readjust it a number of times, and then I got all the rest of these on the first try. So I'm just going to click on done, and now my project is queued up and it's going to start creating the point cloud and the surface model and the orthorectified stitched image uh, from all of those photographs, and I will receive an email notification when that is complete. Now that I've got an email notification, I can come back into Carlson photo capture, and I can download the two items that I'm most interested in, which is the dense point cloud. And so I'll want to download the LAS file, which contains colors, and it also has the projection system burned into it for users' convenience. So you always know the projection that this point cloud was generated in, which makes it a lot easier for us to automatically import it, and you basically have to do less thinking about projection systems. And the other thing that I am going to download is the GeoTIFF image. I could also get the world file, the JPW file, or the GeoTIFF. In P3D, we support both of these geo-referenced images. The JPEG and PNGs here aren't going to be geo-referenced, so you want to download the geo-referenced version of these files. And once I start the download process, so if I just click on it, it's going to start downloading, which I've already done. So I'm going to show you that you'll get these zip files. So one will be the dense point cloud zip file, and so all I'm going to do is just open that up, and then you simply drag and drop that into your project directory, wherever you want that to live. Once you do that, now we have the LAS file, and in my case, I always like to rename these files so they make more sense. So in my case, I just renamed this to Maysville LAS. So I've already done that. So that's the simple process of downloading the data to downloads directory. You're going to get a zip file for the TIFF file and a zip file for the dense point cloud. You simply open those up in Windows Explorer and extract them to your project directory. Once that's done, and now we're going to go back into Precision 3D, where I have the ground control points that I had imported from Carlson survey and deleted some. I set my projection, and I saved the land XML file so that we could easily drag and drop that onto the Carlson photo capture web application, and then uploaded my images. We went through and we waited for the web service to do a little work, send us an email. We adjusted the ground control points, and we waited another hour or so, and we got another email notification saying that our data was processed. We downloaded it, we extracted the LAS file and the GeoTIFF, and we renamed it. In my case, I just renamed it to Maysville. And I can show you quickly what the image looks like, the orthorectified image. And so I'm not going to bring this in draped. I'm just going to bring it into the scene at a fixed elevation, just to sort of demonstrate. So you can see where our ground control points were on these corners and over in this area. But you can see this is my nice orthorectified and georeferenced image file. But I'm going to turn that off for the moment, and I'm going to go ahead and load the point cloud. So let me go in, and we're going to tell it to use the projection in file because we've already set that up, and this process makes it very easy. So you don't, once you set it up, you don't really have to think about it too much. And we're going to go back and go to our projects directory. We're going to choose this LAS file, and we're going to see that the projection is burned in, and if I hover my mouse over that, it'll give me the full projection, what's known as the OGC well-known text format. But it's telling us that we did find it, and that's all good. We know our projection. We want to work in Kentucky North, U.S. survey feet. And basically, it's got 3.5 million points. It doesn't have any classified data because, unlike LiDAR, many drone aerial photograph point clouds don't pre-classify data. That is, identify ground points and tree points and water points and so forth. So I'm just going to go ahead and load this cloud. And that'll just take a few seconds, and then we can come in here and verify that our control points are actually on the corners, just as expected. And if we'll go down here to this point number 8, again, it's right where the monument is supposed to be. And I think we had another point over here, which is right on the corner of this parking block. And I think we might add one more, which is in the corner of this parking lot as well. So you can see that our Carlson survey ground control points that we already had in the scene and that we used to process the photographs from the drone, now when we bring in the fully processed point cloud, you can see this really nice point cloud, and that the ground control points match pretty much spot on. And so I'm told it's within a few centimeters of actual, and it certainly appears to be so. And that's the process of flying your drone, gathering your photographs, importing your survey data into P3D, preparing it in a simple manner, and drag and dropping your images and your ground control land XML file to the Carlson photo capture application. It's going to process the data. You answer just a few questions. It only takes a few minutes. You wait 1 to just a few hours. You get notified that your project is done. You download the data, and you simply bring it in, and you can see that it lines up beautifully. And now I'm ready to continue processing this data for whatever purpose you flew the drone for.